Hello everybody and welcome back. Root Beer here with more GeoGebra fun as we do more basic straight edge compass constructions. What I'm going to show you how to do in this video is create a parallelogram using only 3 points, and these 3 points will give us the corner. So it'll be AB will be one side, AC will be the other side, and then we'll have some other point here so that C, let's call it D. So CD will be parallel to AB and BD will be parallel to AC. Okay, so that's what we're going to do in this video. So the first thing I'm going to do is I'm going to use my straight edge to connect up AC and AB. Now, I think there's a couple ways to proceed, but I'm working from my memory, just trying to demonstrate that you do sort of retain this stuff after a while. What I want next is to create a line going through C that is parallel to A and B. So, can't use the straight edge tool. There's nothing to work with there. So we're sort of stuck using the compass, and I'm going to use the compass to get something centered at A and on point C. Okay. So from there, we have these intersection points of the line AB and this circle. And so I'm going to create a perpendicular bisector through A. And we've probably seen that many times, depending on what order you're watching these videos in. So we get our line going through A right there. Okay. So now this is perpendicular to AB. It goes through A. If we could find sort of some point on here so that that point and C connects up and is perpendicular to A and this line here, then that line going through C would be parallel to AB. So I'm going to distinguish this point, the intersection of this perpendicular bisector and the original circle that I drew. So now, if I connect it up to C, it's going to intersect the bigger circle exactly once. Both this point and C are going to be on opposite sides of this line perpendicular that's through A. They're going to be opposite sides, so if we connect them up, well, what have we got? We've got a chord, and it's going to be perpendicular to the line that's perpendicular through A. Okay. So you can show this with some equilateral, or not equilateral, isosceles triangle work, but there it is. Now we've got a line going through C perpendicular to AB. So I'm going to hide some of this stuff and plan my next move. But yeah, we can even show as we move around, really is perpendicular. Oh, and there's a point we missed. So we'll hide that point there. Alright, so we've got our line parallel to AB through C. We want to make our parallelogram. So there's a couple ways we could do this. We could do the exact same procedure and get a line through B that's parallel to AC. That would be perfectly fine. Another thing, and so, you know, then the intersection of that line and the line through C would give us our fabled other point D, making the parallelogram, and that'd be fine. Another thing I think we can do, we connect AB. If I bisect this, if I get the midpoint here, think about diagonals of a parallelogram. They split each other in half. So if I can find the midpoint here, the line going from A through that midpoint has got to be part of the diagonal, the missing diagonal, not the BC diagonal, the AD diagonal. So wherever that line intersects the line going through C, we'll be all set there. So how do we find a midpoint? Well, perpendicular bisectors to the rescue. So this gets us our point here through A. Now, if we connect these up, we've got a point out here. And this point is indeed the other point on our parallelogram. We'll give it a name. I guess it's M is where the system's taking it. So if I hide these lines now, and I do mean hide all of them, we can create our parallelogram. And we'll move it around and get the lines really close to one another and say, yeah, they really are parallel. But we don't need to do that. The math says it's going to work as is. So this is how we do our construction. Line segment, what color? Light blue, I guess, was the last thing I used. How about hot pink? So here we have a nice little parallelogram. And we can move the points around, and oh geez, doesn't that look good? CM, when you get them really close, they really look parallel. Now it's degenerate. Fantastic. And as I say, this wasn't the only way you could have done it. The technique we used to get a line through C that's parallel to AB, you could have done the exact same procedure, get a line through B parallel to AC, and that would have also given us this point M. But it's there. I can't move M, but I can move all these other ones. Fantastic. We get ourselves a parallelogram, and you can too at home as long as you got a straight edge and a compass. Do be careful with the compass. The point that sticks in the paper can be quite sharp. But that's all for me. I'll get another construction and upload it sometime in the future. There's a bunch of these things. They're fun to do. So long for now.